Hey, we've all seen it in the movies. Space travelers jumping through a glowing portal and popping out on the other side of the galaxy, or even in a different century. But in the world of theoretical physics, wormholes aren't just a sci-fi plot device. They are a legitimate mathematical solution to the equations of general relativity. This is the study of shortcuts in spacetime, and while the math says they could exist, the reality is a lot more complicated. To understand a wormhole, think of spacetime as a flat sheet of paper. If you want to get from one side to the other, you have to travel across the entire surface. But if you fold that paper and poke a hole through it, you've created a bridge. In physics, this is called an Einstein-Rosen bridge. Mathematically, a wormhole is a tunnel with two ends, each at separate points in spacetime. These could be billions of light years apart, or even in different universes. But here's where the reality part hits hard. According to the math, wormholes are incredibly unstable. The moment a single photon of light, or a spaceship, tries to enter, the gravitational pull would cause the tunnel to pinch shut and collapse instantly, crushing anything inside. To keep a wormhole open, you would need something called exotic matter. This isn't just normal stuff like gas or dust. It's a theoretical substance with negative energy density. It would literally push outward against gravity to hold the throat of the wormhole open. The problem, we've never found any, and we're not even sure it's physically possible for it to exist in large amounts. But it gets even weirder, because if you have a wormhole, you technically have a time machine. If you took one end of a wormhole and moved it at the speed of light, or placed it near a massive black hole, time would pass differently at that end due to time dilation. If you then stepped into the fast end, you could theoretically exit the other end before you even left. This leads to massive headaches like the grandfather paradox. If you travel back in time and accidentally stop your grandfather from meeting your grandmother, you would never be born, which means you couldn't have traveled back in time to stop them in the first place. Because of these paradoxes, many physicists, including Stephen Hawking, suggested the chronology protection conjecture. This is the idea that the laws of physics will always find a way to prevent time travel to the past, perhaps by making wormholes impossible to stabilize or causing them to explode the moment a time loop forms. So while the math of Einstein allows for these cosmic shortcuts and time tunnels, the universe seems to have a very strict no-cheating policy when it comes to the speed of light and the flow of time. So the next time you see a character jump through a portal in a movie, remember, they're navigating one of the most brilliant but dangerous loopholes in all of physics. Pretty wild, right?